Guys, I'm going ahead and starting the next review video, which will go over hopefully the rest of packet 1 for you. And I will not go over the quiz because you're going to be required to do that and turn that in, at least for my kids. For those of you that are in other classes, I can happily go over those answers with you later. So, okay, so when we solve equations, remember we want to isolate the variable. We want to get it all by itself. And so I'm going to kind of take you through, since we've all learned how to solve equations, I'm going to take you through how to do some of these. If you want to go ahead and pause the video and try some of these on your own, that would be definitely a good thing to do so you can see where you get stuck. Remember that when you have parentheses, like down here, you're going to need to distribute first. So we're going to go step by step. So the first thing we want to do is get rid of any numbers that are around the variable or the term with the variable. So I'm going to go ahead and take 3 from each side. An equation in algebra is like a scale. We want to balance it, so whatever you do to one side, you have to do to the other. So 18 minus 3 is 15, and I get a negative 3a. Now, a lot of times what I do is I go ahead and I cross this off so that I know that it's not coming back, okay? And I can also draw a line right through the equal sign to know that when I go back and forth, I have to use inverse operations. Okay, so while doing this, I see that this has negative 3 times a. So then I ask myself, what is the opposite of multiplication? And that is, of course, division. So I'm going to divide by negative 3 on both sides. And I get a is equal to negative 5. Always remember that a positive number divided by a negative is always a negative. Remember, if the signs are the same when you add, multiply or divide, it's going to be positive. If they're different, it's going to be negative. Okay, just a little bit of integer review for you guys. Okay, now, so what's always confusing to people is when they see this 4 over here right next to a minus sign. Now remember, if I had a sign assigned to the 4, it would be on the left side. So this negative, or this minus 1/2, belongs to the n, all right? Or the minus belongs to the 1/2, which belongs to the n. So this 4 is positive. So you always want to look at it and say, is this positive or negative, okay? I'm going to subtract 4 from each side, and I get negative 1/2 times n. Now, a lot of times I say these out loud so that I remember that what I'm doing, so it helps me remember which inverse operations to use. And then negative 12 minus 4, remember if the signs are the same, add them together and keep the sign, so that's going to be negative 16. All right, now, I'm sorry, it should be x equals negative 16. I apologize. I'm not writing mine. Big cue to you guys is to try to make your work as neat as possible. It's easier for your teachers to follow, and it's easier for you to prevent any mistakes. Okay? So, now I divide both sides by -1/2. Okay? I can do this very easily. Before I use fractions, I know you guys always tend to kind of get a little bit frazzled, and that's okay because that's why we have a calculator, right? So the first thing I'm going to do is take the negative 16 and I'm going to divide it by a negative 1/2. So I'm going to divide it by, and I'm going to use my alpha y equals, okay? I do negative 1 on the top and 2 on the bottom, okay? And that's equal to a positive 32, okay? And that makes sense because a negative divided by a negative is a positive. Remembering when you're dividing by fractions, you always multiply by the reciprocal, which is the flipped fraction. So just a little bit of review of middle school math, which we try to forget, I understand. So just hang in there. Okay. All right, so moving on. So we're getting gradually more and more complicated with our problems. So this is a two-step problem. I can subtract 17 from both sides here, right? So I get rid of that 17. I get rid of my constants first. And I have 3/4 x is equal to, remember that's 3/4 times x is equal to 23 minus 17, which is 6. Now, I can just divide by 3/4 if I wanted to and just use my calculator. Or a lot of times what I tell my students to do is multiply by the bottom number of the fraction first. And I get 3x is equal to 24. And then I divide by that 3. So x is equal to 8. Or you could also use your calculator, and I'll just show you what that looks like. So if I use 6 and I divided it by 3/4, because this is being multiplied, so the opposite of multiplication is division, so 6 divided by alpha y equals, and then I do 3/4, 3 divided by 4, and I get 8. So it's exactly the same thing. So if you want to go ahead, practice using your calculator, that's totally fine. All right. We have parentheses here. That tells me instantly that I'm going to need to distribute. I'm going to distribute -4. I have to keep the sign with my number. So I'm going to distribute -4 into here. So I get 9y. Make sure you keep that number right here, okay? Then I have -4y minus 4 is equal to 31. -4 times y is just -4y. -4 times +1 is -4. Okay? So after I distribute, I'm going to combine like terms here. All right? So I distribute, and then I'm going to combine like terms. All right? And so that's 9y minus 4y is 3y minus 4 is equal to 31. After I combine like terms, I'm going to add this because I see this 4, right? So I'm going to add 4 to both sides. And I have 3y is equal to 35. I'm sorry, this should be a 5y. I apologize, guys. Ugh. This is what happens when you try to do math on a Saturday morning. 9 minus 4 is 5. So I apologize for that. 5y. I was wondering why that wasn't going to end up being very pretty. So then we divide by 5. Okay? So y is equal to 7. We can always check to see if this is our answer. If we plug in 7 for y, or like here, we can plug in 8 for x and make sure we get 23. All right? Now, when we have variables on both sides, we need to follow those same steps and hopefully not make any math errors like I just did. And so we're going to distribute. We're going to distribute on both sides here. So I have -6w plus 24 plus 8w is equal to 2w plus 18. All right, now be very careful. We want to combine like terms first because it's just neater to do it that way, and then bring the variable over to one side. I tend to focus to bring the variable over to the left. It doesn't matter which side, and a lot of times people just bring it over to the side where it's the most positive. And that's where it is positive, and that is absolutely fine. It makes complete sense. All right, so I have -6w plus 8w. Hopefully I can add these correctly this time. So that's 2w plus 24. I can't write either, apparently. Is equal to 2w plus 18. See something a little bit curious here. Okay, so look what happens. I have to take my 2w and I'm going to try to bring it over here. But then my variable goes away. I end up getting 24 equals 18. Well, that's not right, okay? So when our variable goes away and our two numbers on either side of the equal sign are not the same, that means there's no solution. Okay? Now, let's try this next one. Here, I'm going to distribute a -1. So you need to imagine a 1 right here. okay? Because you're subtracting the 7m and subtracting the 12. So you get 3m minus 7m minus 12 is equal to, and then I'm going to distribute 2m minus 6. Okay? So once again, I'm going to combine them over here. I get negative 4m. Please be very careful with your signs, okay? And this is why I always tell my students to try to really be neat, because it does help you a lot. It prevents mistakes. So now I get to bring my variable over to one side. Now, a lot of people don't like the fact that they have a negative variable here. So I'm going to bring it over here. It doesn't matter which way you want to do it. It's fine. I'm going to bring this 4m over to this side so I can have a nice, pretty variable, positive variable. Doesn't matter, though. Okay? Now, remember to bring down this negative sign right here because that goes with the 12. All right? So we've got 6m minus 6. And then I'm going to add 6. And this is where you have to be very careful with your integers. You've got negative 6 equals 6m. And I'm going to divide each side by 6. So m is equal to negative 1. All right? And again, remember that you can always check by plugging it back in. I hope that you do that, especially while you're taking your SOL. So definitely try to do that. So we're going to keep going. Okay. And here we have another equation. Okay, so we have to distribute. So we're going to distribute this negative 2. Do you notice how I always include that sign in front of it? Okay, so I have 2x. I carry this guy down. Negative 2 times 4x is negative 8x. And that's plus 6. And I get equals 6 minus 6x. Okay, so then I'm going to combine like terms right here. And that gives me a negative 6x plus 6. And this is 6 minus 6x. Well, if you haven't been able to tell yet, these two are exactly the same thing, but let's go ahead and take it to the next step. All right? So when I add 6x to both sides, my variable ends up going away, and I get 6 is equal to 6. Okay? Now this one isn't as problematic as the other one because my variable did go away, but these numbers are exactly the same. Now keep in mind they always have to be exactly the same. So if they had different signs, they would not be equal. So when this case happens, your solution is all real numbers. Okay? Here, I'm going to go ahead and cross multiply. This is the one that always gets you guys. So you have to multiply here and here. And what I want you to do is you have 7x is equal to 3. Now put parentheses around the x minus 8. It's very important. So I'm going to go ahead and distribute. 7x equals 3x minus 24. And then I'm going to bring my variable to one side. So I get 3x, 3x. I get 4x is equal to a negative 24. I don't just get rid of this sign because I don't like it. We have to keep it there. We have to take care of it. And I get x is equal to negative 6. All right? Okay, moving on. We're doing literal equations, which are always a doozy for you guys. Okay? One of the things that I try to do is really highlight what I'm trying to solve for. Okay? I'm trying to solve for h here, and they want me to solve for b here. So first thing I always do is take care of all the numbers that I have around it. So I need to get rid of this 1/2. I can divide by 1/2, or I could just multiply both sides of the equation by 2. Okay? So I get 2 times a is equal to b times h. And again, I'm solving for h. Now, how do I undo multiplication? I just divide. Okay, so this is why I always talk to myself. I say, okay, 2 times a is equal to b times h. Because I hear the word times, I know I need to divide. So I'm going to divide by b. So h is equal to 2a divided by b. Okay? All right, not too bad, right? So this guy, what do I do here? I want to get rid of that ugly fraction, okay? So what I'm going to do is multiply both sides by 4, all right? Like 4c, not cc, Lord. 4c is equal to a squared plus 3b, all right? I got to get this guy all by itself. I don't have to take a square root or anything. I just have to get rid of this. So I'm going to subtract it, okay? I subtract it. When I'm moving it from one side to the other, I either add or subtract, and that depends on the sign, right? So I have 4c minus a squared is equal to 3 times b. Now, if I had 3b equals 12, what would I do to solve for b? I would divide by 3. That's exactly what I'm going to do here. So I divide by 3 on both sides, and I get b is equal to 4c minus a squared divided by 3. Okay? Now, the next step is to deal with inequalities, and inequalities are pretty much just the same as equations, except for when we divide or multiply by a negative number. When we do that, we have to flip the sign. Now, just as a reminder, if I have a greater than, I'm going to, and my variables on this side, I have an open circle and I graph to the right. If I have a less than, I also have an open circle, but I graph to the left because it doesn't include those numbers. If I have a greater than or equal to, I have a closed circle and I go to the right, and a less than or equal to, I have a closed circle and I go to the left. All right? Now, if you guys are my students, we haven't really gone over this a lot yet, but it should seem very familiar. You have touched on some of it in pre-algebra, so not to worry. We will go over it some more as well. So, but follow along here. All right. So, what I'm going to do here is I'm going to subtract 13 from both sides, which is exactly what I would do if I was solving the equation. So I subtract 13 and I get 11x is greater than or equal to negative 33. Now, since this number isn't negative, I know that I can just go ahead and divide by 11 and nothing else changes. If I divided by a negative number, though, this guy would flip. So this is x is greater than or equal to negative 3. So I find negative 3 on my number line, which is right here. And do you notice how this guy is pointing this way? Well, imagine that. That's how we graph. Okay? So one of the things that I try to do is always bring the variable to the left side of the equation. Now that may cause that my variable will be negative at times, but that's okay because we know how to deal with that. So here, I'm going to subtract 3x from both sides of the equation. So negative 5x plus 6 is greater than negative 34. Okay? So then I'm going to go ahead and subtract 6 from each side, and I get negative 5x is greater than negative 40. And then once again, I divide by negative 5 on each side. Now look, I divided by a negative number. So that means this guy, we have to change it, right? So now x is now less than a positive 8. So if our signs change, so does our inequality sign. So now we know what that means. We have an open circle and it's going to go to the left. All right? Okay. Now, for this one, we're going to go ahead and distribute first. Remember, just like we do with equation, we're going to distribute negative 7 to both these things. So I have 3x minus 7x minus 21 is greater than or equal to negative 13. So I get minus 21 is greater than or equal to negative 13. And I'm going to add 21 to both sides. So I get negative 4x is greater than or equal to, I've got negative 13 plus 21, and that is 8. And then I have to divide by a negative. So again, that tells me I need to flip my sign. So I divide by a negative 4. So x is now less than or equal to negative 2. So I have a closed circle, a negative 2, and I go to the left. Always go to the left for less than, right for greater than. Okay, so next one, we have 2 times 5x, 5 and minus 3x. So we have 4 minus 8x is less than 10 minus 6x, right? And then I'm going to bring this variable over to the left side. So I have 4 minus 2x is less than 10. And then I have to get rid of this 4. So I'm going to subtract it. And gosh darn, we have another negative variable. So that's going to be 6. So we're going to divide by negative 2. So x is now greater than negative 3. So we go to negative 3, we have an open circle, and we go to the right. Okay, so hopefully those aren't too complicated. I think we have some more. Okay. The other types that we have, you're going to see this more in higher level math, but I'm going to go over them anyways. When we have an or, that means we're going to put them together, and usually and, or is going to usually look something like this when we graph it. And then and, which is exactly what this is going to usually be something like this, right? So I'll show you what that means. So we have to solve each one of these separately. So here I have x plus 7 is less than or equal to 2. So I just subtract 7. So x is less than or equal to negative 5. So I find negative 5, and I have a closed circle, and I'm going to the left. Now I'm going to deal with this guy over here. So I have x plus 14 divided by 4 is greater than or equal to 3. So I'm going to multiply both sides of the equation by 4, all right, to get rid of this ugly fraction on the bottom. So I have x plus 14 greater than or equal to 12, and then I subtract 14. So x is now greater than or equal to negative 2. So then I have a closed circle and negative 2, and I go that way. All right, and I keep going. So again, solve each one of these separately. Go ahead and take a minute, pause the video, and try to solve each one of these separately, and then show me what you get. All right. So what I did here was I subtracted 5 from each side, and I have 3x is now less than negative 21. I divide by 3, and I get x is less than negative 7. The next one is I add 8 to both sides, and I get negative 5x is less than or equal to negative 5. All right, now I'm dividing by a negative here, so I have to remember to flip the sign. Okay, so now x is greater than or equal to positive 1. Remember, that changes. So I have negative 7, I have an open circle on that, and I'm going to the left. Then I have 1, and I have a closed circle on that, and I'm going to the right. Now, when you do these cute little and ones, you're going to deal with what's on the inside, but whatever you do to this side, you have to do over here as well. So you see how I have to add 2? Well, I'm going to add 2 here and add 2 here as well. And I get 0 is less than or equal to 3x, which is less than 12. Be very careful with your signs. You don't want to change them. Okay, and then last step is dividing by 3. These are all positive, so no signs change. So I get 0 is less than or equal to x, which is less than 4. So at 4, I have an open circle, and at 0, I have a closed circle, and x is all the values in between there, right? So that's the way I remember it. Since x is between, that's what it looks like. Okay, so these are just like boundaries. Okay, let's try the next one. So I'm going to subtract 1 from everything here. And I get 2 is less than 2x, which is less than 12. And then I divide everything by 2. So now I have 1 is less than x, which is less than 6. So I have an open circle on 1, and I have an open circle on 6, and I graph all the ones in between. Now, when you guys go into geometry, you're going to start doing this thing called proofs, okay? And that's where you have to justify the step. Now, my students, if you guys have been doing, so if you remember with solving equations, what I did is I usually wrote what I did for each step on the right so that you could see what property I was using, okay? So, for here, do you notice how, in order to solve this equation, I would subtract 16 from each side of the equation to here. So what did I do from here to here? I subtracted. So that is the subtraction property of equality. Okay? And then from there, I can either multiply by 3 or divide by 1/3. And it's really the same thing. So I'm going to say, well, I would multiply both sides by 3. So then to get from here to here, I'm using the multiplication property of equality. Okay? Now, remember that the first thing I say when you're looking at an equation, if you see parentheses, you need to be able to distribute. So that's exactly what everybody did here is they distributed. And they used the distributive property. Okay? The next thing they did was combine like terms or just to simplify. You can write either one of those. All right? And then from here, we got this, right? So then I would have to add, right, to get rid of that 5. So from here to here, I use the addition property of equality. And then always my last step is to divide. So that is a property as well. It's the division property of equality. Okay? All right. I know that seems kind of complicated, but it's really, you're solving an equation and you're using those properties every time you use them. We just don't always bring your attention to it. So let's try one more on the other side where we're substituting. Okay? So this is a little bit more complicated. So to get from here to here, they substituted 5x in for y. So they used the substitution property. And remember, you're in the substitution property, you're just replacing something with an equivalent thing. So that is the substitution property. And then from here to here, I have to subtract 2x from both sides. So again, I'm using the property of equality. And then my last step is the division property of equality. Okay, now here we go to your favorite part, which is word problems. Okay, now we have an equation, right? It says the height with w is represented by this equation. How many weeks will it take the plant to reach 1 foot? So 1 foot equals how many inches? 12. Okay, so 12 inches is equal to 1.2 times w plus 3. So in order to solve for that, I just take away my 3, and I get 9 is equal to 1.2 times w, and then I divide by 1.2. And I get w is equal to 7.5. So you would say 7.5 weeks. All right. So let's look at number 55, and then I'll let you guys pause the video and look at these other 4. Okay. The Ravens scored 13 more than 3 times the number of points that the Bengals scored. Okay. So let's look at this. The Bengals scored a certain amount, right? And then the Ravens scored 13 more than 3 times that. Okay. If the Ravens scored 40 points, how much did the Bengals score for? Well, if the Ravens scored 3x plus 13, and that is equal to 40, all I need to do is solve for x. So I'm going to go ahead and subtract 13, and I get 3x is equal to 27, so I divide by 3, and x equals 9. So the Bengals scored 9 points. Okay, so Max is making a rectangular garden with a lake that is 5 feet less than twice its width. So let's look at this. Here's your rectangular garden. Here's your width. All right, remember that your length or your perimeter is 2 lengths plus 2 widths, right? And then the length is 5 feet less than twice its width. W minus 5. So if I take 2 lengths and 2 widths, and I say that that perimeter is 80, I solve for W. Okay? So I have 2W plus 4W minus 10. And I get 6W equals 90. And then W is equal to 15. So W is 15, and then 30 minus 5, this would be 25. Okay? All right, that one was a little bit more complicated, so just definitely go back and take a look at that one. Sydney, Macy, and Allie are sisters. Macy is 2 years older than Sydney. And Allie is 1 year less than half the age of Sydney. Okay, so if you notice, everything's in terms of Sydney. So X is equal to Sydney's age. And Macy is 2 years older, so that's Macy. And then Allie is 1/2 Sydney's age minus 1. Okay, so if we add it all up, I got x plus 2 plus 1/2 x minus 1 is equal to 31. If I add together, I get 2.5 times x minus 1 equals 31. So I get 2.5 times x is equal to 30, and I divide both sides by 2.5. And I get x is equal to 14 years. I'm sorry, X is 12. Sorry. And then Macy, which is 2 years older, Macy is 12 plus 2, which is 14. Okay, let's do the last two. The expression 400 plus 0.15 times S represents Frank's weekly pay as an appliance salesman. If he wishes to make $1,600 this week, how much will he need to do in sales? So if he wants to make $1,600, he uses this equation, 400 plus 0.15 times S. Okay, so I take away 400 and I get 0.15 times S is equal to 1200. And I divide by 0.15, and that's 8,000. Okay? All right. Now, 38 plus 65. She can spend a maximum number of $200. So how long can she rent it? So we'll just go ahead and do less than or equal to. So I'm going to take away 65. So 38 is less than or equal to 135. And then I divide by 30. And my hours are less than or equal to 4.5 hours. Okay? Oops, sorry guys. So hopefully that helps you, that gets you through the first packet. That's for week 1. And we're going to keep reviewing. Please keep, I hope that you guys can work on quiz 1 and turn that into me, and then we will work on packet 2. All right? Have a great day, you guys.